Hi, today they're tracking us! Who's tracking?
Why haven't you put your room together yet?
I thought it was your job.
They are tracking us in the streets. They know when we stop and when we go.
Who is tracking?
Don't believe me? Let me show you.
Okay, calm down. What's going on? They placed sensors in the streets and are tracking cars. Didn't we already? These sensors, see? Oh, these. But we already knew about these. Maybe we knew, but you know how many people ignore these? These are here to control us. Control us with what? With those. Right, these are traffic light sensors, obviously. Do you know how much delay and confusion people cause every day by not stopping on these sensors at the intersections? So this was all a public service announcement? Yeah, they delayed it. Sorry. You shouldn't jaywalk, especially when distracted, you know? Yeah, that was embarrassing, but I just wanted to make sure people know these sensors exist and they must stop on them behind the red light. Otherwise, the light may never change. I know, but why do you care so much? I have been stuck behind the drivers who didn't know about this.
Idiot.
See, these sensors detect if a car is present behind the traffic light, so the traffic light knows to change green for the cars to pass. Not all intersections have it.
But if you see them, stop on them so the light changes.
The sensors, calm down, come in pairs of big loops like these, probably to cover the entire length of the car. You only need one set of these to detect if a car is behind a red light and then the light goes green. But sometimes, for example, in left turn lanes, they don't want to always turn the left turn signal on and hold the entire oncoming traffic for a single car to turn. So in some crowded intersections, they put two pairs of sensors, one car apart, and they both have to be occupied for the left turn signal to turn green. Which means there must at least be 3 cars behind the red light for their signal to turn green. So in these intersections, when I only see one car stopped on the first sensor, I stop on the second sensor to make sure my light turns green.
You monster.
But I wonder how these sensors work. It must be a weight sensor with a high weight threshold, so something as heavy as a car would trigger it.
Your mama would trigger the sensor.
You idiot! It's our mama you're disrespecting.
Oh, sorry.
What's going on, boys? Holy
Nothing.
Holy hell, it's getting worse. Where are my pills? Let's see. Oh, the sensors are inductive loops. If so, it is not weight. It is a giant metal detector.
Oh, so it is magnetic radiation.
What? They are cooking us alive in our cars? Nah, Mom. They are very low frequency and power. Why am I talking to myself? Where are my pills? The way these sensors work is quite simple. They are basically made of a giant loop of wire, and if you place an AC voltage across it, some AC current will go through it depending on the impedance of the loop. Now if a car, for example, which is made of steel and is a giant ferromagnetic body, stops on the coil, the magnetic fields created by the coil are magnified through the body of the car. The inductance of the coil significantly rises, the impedance rises, current drops, you detect these changes and you know there's a car.
No, it's like one of those credit card readers that you tap your card on it, it powers your card and reads the information. What if government has a chip on every car and knows exactly where you're going at the intersection using those sensors?
I guess they could. It's okay, I don't have anything to hide.
Speak for yourself.
Fine, I guess I can measure it. I need a portable scope. That's cute, but I like to have the bigger screen. Okay then, I have a 12-volt battery and a car inverter and we can plug it in. What are you doing? Stand back. I'm making my scope battery operated. Not the 4-channel scope, at least use the 2-channel. Okay, fine. Let me see.
Do you even know how it works?
My boys, I should find them a wife so they turn into proper men. I think you should take your pills. Yeah. Oh, there it is. All better. Okay, now we can start opening it up. Let's see how hard it is to make it battery operated. A good scope is the key way to all electronics. And thanks to my sponsor Keysight, I'll give away 2 more of these 4-channel scopes plus 1 fancy power supply that I still don't have. You know, Keysight and I are best buddies. Not only they keep educating people through their Keysight University and their YouTube channel Keysight Labs, They keep providing free tools to my people. All you need to do is to sign up for Keysight University for free. Oh, I mean, if you signed up already through my link, learnkeysight.com/ElectroBOOM, then you're already in the draw. Otherwise, go ahead and start learning for free. Because scopes need to go into hands that can appreciate their beauty. It's like a tank covered in an iron shell. Wee, look at this. There is a power supply module that with a bunch of cables is powering the motherboard, and on the other side is powering a 12-volt fan. Without killing ourselves or the scope unnecessarily, let's see if we can measure the voltages. I assume these metal shields are ground, so let's check the voltages. 1.2, minus 18.2, minus 7.3, 5.15, plus 17.8, 7.2, ground. And this is when we realize that it's more complicated than we can handle. Haha. I was hoping there was a single DC voltage going to the motherboard and the motherboard was making all the voltages it needed. That way I could use a battery to make that single DC voltage. But now it's much more complicated. Well, let's open up the power supply and see if there is any chance. Well, the AC goes through a fuse and a bunch of EMI filtering components into a full bridge rectifier back there. And beside this 12-volt regulator chip that feeds the fan, all other DC voltages are switched straight from high voltage. So let's dig deeper. You know, there comes a time in every man's life when he says, F it, let's put everything back together. You know, simple solutions are often the best. I'm gonna take my 12-volt car inverter and create a 120-volt on the spot and just plug it in. Ah, I lost the screw. Oh well, seems to be working. Of course it works, I'm the best! Let's focus on measuring those magnetic fields. I think I'll make a large coil of wire that will convert the magnetic fields into voltage I can measure with my scope. You know, the larger the dimension of the coil is and the more number of turns creates higher voltage. Oh wait, I already have this, which I made in some video. It is just a flat coil of wire, which is good because if I put it on the street, it won't create a bump. So I just connect my coil at the end of this cut extension cord and I can measure my voltage at the other end. And of course we need duct tape. So here's the plan. Imagine this is the street sensor that right now I'm driving with a 100 kHz signal you see on the yellow line. And this is my probe coil that I'm measuring on the green line. And if I put it on the street sensor, you see the output rises. Now if a car drives over the coils, vroom, 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 you see it affects the output voltage. Although I was expecting it to rise, why is it falling? Well, this is interesting. This is my coil series to the resistor to the generator. And you see at 1 kHz, the voltage rises, meaning the inductance is increasing. But at 50 kHz here, the voltage is dropping. So depending on the frequency, we might see different effects. Let me duct tape my sensor to the ground so it doesn't move easily. Look at my tiny coil over this big sensor. Maybe it's too small to pick up anything very useful. Oh look, I'm reading something. There seems to be noise. This you see here is just noise. Well, I was still able to detect some changes when the cars were passing. Evidently, simple solutions are not always the best. There was tons of cars going around, but now that I'm waiting for one, there is none. There's one coming. Let's see if there's any difference in the signal. There. Oh, there was there you go. There was some tiny change. Let's look at these cars passing. Oh, there was a change. Let's look at the signal over a very low frequency to see, because the car passes slowly. Maybe we can see a bump here. Whoop. Well, let me pull my sensor off the ground and see if the signal actually goes away or I'm just on crack and I'm measuring random environmental noise. Did it go away? What? It's actually more. What the f was I measuring? Unfortunately, I realized that the signal I was trying to sense was so small compared to the noise generated by my power inverter that it was pretty much drowned in it. Probably that's why my crazy side was trying to make the scope battery operated. Running a scope on battery makes sure that there is no noise created from your power generators. We saw some effects of the car passing over the sensor, which is in their frequency, amplitude and phase, things that metal detectors use. I should design my own metal detector. So you're saying you couldn't figure out if the government is tracking us? Oh, you're back. Yeah, your pills are wearing off. Government doesn't need to use these sensors to track cars, you know, and they are used on one in every like 20 intersections anyways. And why use them when intersections like these ones have cameras on them? No! Yeah, look at this. I was just picking up the noise coming from my power inverter. That's why I wasn't able to see the tiny signals from the street sensor. A purely battery-powered scope would help with that. That's why it's important to know how to use your equipment properly. So sign up for free for Keysight University from my link if you haven't already, and start learning important stuff about scopes, power supplies and other tools. And you could also win one of the 2 scopes and a fancy power supply I still don't have. Keysight has added tons of new courses since last time around the test and measurement space you would really benefit from. And that's on top of all the great content they created in their YouTube channel, Keysight Labs, that's filled with electronic knowledge. Go and subscribe to their channel now! And thank you for watching.